Hiya Six and welcome to Friday's geography lesson. Today's lesson is following on from yesterday's on the layers of the earth. So we learnt yesterday that the earth is made of the crust on the outside, then the mantle, then the outer core and then the inner core. Today, we're going to think about the function of the tectonic plates. So we're going to be looking at the crust, the outer layer of the Earth's surface, the bit that we live on with the land and the oceans. And we're going to have a look at the different pieces that make up the crust. Before we start, as a bit of a warm-up to get your geography brains working, can you pause the video and can you try to remember the 7 continents of the world? Come back when you've got them. Okay, well done. Hopefully you have listed them as South America, North America, Africa, Europe, Asia, Australia, and Antarctica. Well done if you remembered all of them. So, tectonic plates. Yesterday, we talked about the surface of the Earth being the crust, and we did talk about it being made up of different plates. Now, this is a map of the Earth, and you can see the lines that I've drawn here are showing the different plates. So they're almost like pieces of a puzzle, really, and they're the different parts of the crust all joined together. Now, the tectonic plates can move about slightly. Okay, remember the crust sits on top of the mantle, and the mantle is like a layer of magma, kind of what comes out of a volcano. And so the plates can move about on top of that because the mantle is softer. So let's have a look at the world map. And if I can direct your attention to this part here, imagine what would happen if we moved this piece of land, Africa, over here to this piece of land, South America. So at the moment it's got Atlantic Ocean between it, but actually, look really closely. Do you think those two pieces could fit together? This bit here kind of slotting into this bit here? What do you think? So, a scientist named Alfred Wegener, 1910, was the first person to come up with the idea or study the idea that all our continents had once fitted all together like a jigsaw puzzle. Now, at the time, people weren't sure whether he was right or not, and it wasn't until the 1950s, actually after he had died, that experts began to realise he was right. The continents, the landmass, and the ocean floors, the bottom of the ocean, float on moving rock plates, and they are actually drifting, so they do move, and this is what is known as continental drift, that they can just drift and slightly move and they are floating. To support his idea, Wegener had looked at different fossils and where they were found, and then he was able to piece back together where they must have been. So for example, he found a fossil here of this land reptile which had been found here in South America, but also here in Africa, which suggested to him that at the time, these two places must have been joined together, because there was no chance that a land reptile could live here and then also get over there if it was all the way across the ocean. So this is a representation of what he believes that it did look like once upon a time. They were all fitted together. Africa, South America, India and Antarctica come up there. So it's really quite interesting. And it's really quite interesting how he used fossils to help to prove where they had been and where they fit together. And if you do look back at that world map, you really can see how they would begin to fit together like pieces of a jigsaw puzzle. So let's find out a little bit more. Now, we are talking about a very, very long time ago. So Wegener named the landmass, so where all of the continents were joined together like a jigsaw puzzle. He named that landmass, that joined up place, as Pangea. Okay, so when they all fitted together, he named that as Pangea. Now, this is 250 million years ago. And over time, if we follow these arrows over time, we're still a long, long time ago, 200 million years, 145 million years, the land mass starts to split apart, okay? And we start to get these separate land masses. And here in the Jurassic period, 145 million years ago, it's starting to look a little bit more like the continents that we recognise today. Okay, and here we've got 65 million years ago, and it's looking even more similar to what we know. And then here, the present day. Okay, so they've split even further apart. So this looks like a world map that we recognise today. Now, the plates are still moving. Okay, they currently move about 1 to 10 centimetres every year. So they are always on the move. They can move in different ways. So 2 plates could move towards each other, 2 plates could move away from each other, or 2 plates could rub alongside each other, like that. And as we're going to go on to find out, the way that plates move and the way that plates join helps to form certain different features of the Earth. So, what you are going to do today, and there's one more video that you can watch on YouTube that will help you with this, but I will introduce it first. So what you're going to do today is create an information page on tectonic plates. So your page should end up looking like this example page. You're going to have an introductory paragraph, and then you're going to go to YouTube and learn more about these specific different types of plates. So I have explained to you in this lesson what tectonic plates are. Okay, the different parts of the Earth's crust made up into different sections, always moving. And we've talked about how they can move in different ways. So already you will be able to do this first part here. So you need to write your own, a little short paragraph explaining what you understand tectonic plates to be. Okay, you might talk specifically about the scientist Alfred Wegener and his theories and how he used the fossils to prove it. You might want to stop the video, go back to the beginning, watch the first part again to remind yourself, and that's absolutely fine. But you should have the information within this video to do the top section. Then stick with it and carry on to find out more about the specific types of plates. So I mentioned plates that move together, plates that move away from one another, and plates that rub alongside each other. The YouTube video, for which there's a link on the website for, will go into a little bit more detail on this and help you to draw your own diagrams for the different types of plates and to write a little bit about the different types of plates. Okay, so your job now is you can start by doing the introduction paragraph and then go and watch the YouTube link about the different plates to finish off, okay? And you could end up looking something like this. So you will see how the plates end up creating mountains and volcanoes and earthquakes, and it's really very interesting. I hope you enjoyed learning about that. I hope you enjoy learning about it in more detail. We really look forward to seeing your final piece of work all about tectonic plates. Next week in geography, we're going to zone in on mountains and have a closer look at those. See you in the next lesson.